Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are doing Chapter 70, Question 3b. This is a continuation from a different tutorial video, but that one was a bit too long, so I've decided to shift this over to a new video. Okay, so we are going to be anti-deriving tan cube of x, but this is a definite integral, so we'll be subbing in some numbers as well. So your answer should be a value, or should be a number, okay? This is actually harder than it looks. So tan cube of x might look deceivingly easy, but it's actually quite confusing on how you actually go about this. So first of all, what kind of function is this? Well, we know it's a tan function, but it's a tan cube function. So that's an odd power function. If you have an odd power function, as I've described in the topic video earlier, if you haven't checked that out, make sure you check it out first and then come back to this video afterwards. I'll leave a link below, I'll leave it on the pop-up as well. So if you have an odd power function, what you want to do first is split the power into 1, so to the power of 1, tan x, and split it into the even power. So the leftover, whatever the leftover is, split into the even one, okay? But you always must have a 1 by itself, right? And that's because we're going to do substitution later, which is technique number 1. Okay, so afterwards, after you split it, you convert the even power into something else. So you have to use identity rule. And the identity rule we're going to use here, if you remember, 1 plus tan square of x is equals to sec square of x. So therefore, tan square of x must equals to sec square of x minus 1. So I'm just going to rewrite sec square of x minus 1. That is the same as tan square of x. Okay. Then afterwards, what do you do next? Well, unlike your previous one, so this is the reason why this is hard. If I was to let u equals, sec x, and then I derive du dx, it doesn't give me just tan x. We can actually have a try here. It doesn't give you just tan x by itself. It gives you something else, but this is why this question is actually hard. Right, let's try. So let u equals to sec of x, which, as we know, is 1 over cos of x. And then let's try deriving that. So what is du dx? Well, du dx, if we derive this, that is using quotient rule. So that is cos square of x, I just square the denominator. And then I derive the numerator, which if I derive 1, I get 0. 0 times anything is 0, so you can just have it as 0. Minus, now I derive the function at the bottom. If I derive positive cos, I get negative sign. So minus sign is positive sign, and then I just times it by 1, right? Which gives me sine x on cos square. And here is, I guess, where you can kind of see the problem with this. Sin x divided by cos x is tan of x, that's fine. And then you still have a cos x on the denominator, because that's a cos square, not a cos of x, it's cos square of x. So it's tan x divided by cos of x. And as we know, the tan x, yes, it will eliminate the tan x, but then you have a cos x as well, which is kind of a problem, right? You have a cos x over here. Okay. This, don't stop there, you're almost there. You actually just have to go one step further right here. So let's find dx first. Dx would be, you bring the dx up here, you bring the cos x, you bring the tan x down, would be cos of x divided by tan of x times by du. Okay, I'm going to rewrite this equation once again. Okay, so, and just be careful. When you put your definite integral, this is pound 4 to 0. That is in terms of x. Now we're going to use u, okay? So u is sec of x. So before you even write pound 4, 0, you need to make sure you find what the u values for these are. Because that's the x values, not the u values. So for x equals to pi on 4, u is equals to sec of pi on 4, which is 1 over cos of pi on 4. Cos pi on 4 is 1 on root 2. So 1 over 1 on root 2 is... just going to write it here, 1 on 1 root 2, that is root 2. And then of course, with x equals to 0, that is u equals to sec of 0. And 1 over cos of 0 is 1 over 1, which is 1. So that's fine, we have root 2 and 1. Okay, I'm going to rewrite this equation once again. So this one right here, tan x sec square minus 1. Tan x, that's fine. The sec square becomes a u square minus 1. And then the dx becomes du over tan x, but then times by cos x. So I'm just going to replace it here, okay? Times by cos of x, okay? And what are we left with? Well, it's root 2, 1. the tan x cancels out, which is always nice. You know, you get it to cancel out, but then you're left with u squared minus 1 du times by cos of x, which is a problem. You still have an x in there. You can't just anti-derive u and x together, right? Okay, this is where the trick comes in. What do we let u equals to? U was sec of x, so u is equals to 1 over cos of x. But then what is cos of x then? So this is kind of like manipulating your equation a little bit, similar to linear substitution, but not quite. But of course, if u is 1 over cos of x, then cos of x is 1 on u. So therefore, you can write this as root 2 1 u squared minus 1 times by 1 on u. Okay, and then anti-derive in terms of u. And once you get up until this part, guys, you can see a polynomial coming up. So root 2 1 u squared divided by u is just u, and then this becomes 1 on u and du. And then now we can definitely anti-derive this. So what is the antiderivative of u? That is half u squared. What is the antiderivative of 1 on u? That is u to the power of negative 1. Don't add power, don't use polynomial. It turns into a log e mod of u. And then you sub in the root 2 and the 1. Okay. And then we're almost done. Sub in the numbers and then you should be done after that. Okay, we sum in root 2 squared is 2, 2 divided by, or 2 times half is 1, minus log e mod of root 2, which is still the same as log e, actually, mod of root 2, yeah, that's positive root 2, and then, so I'll put in the bracket, and then minus, I sub in 1 this time, and I get half, minus log e mod of 1, which is log e of 1, and then, we get almost there, 1, so, we expand everything, log minus log e of root 2, minus half plus log e of 1. Log e of 1, what is log e of 1? That is 0, so it's plus 0. And our final answer is half minus log e of root 2. There we go, guys. This is how you do this question right here. So I know it's quite long, but that's pretty much special, guys. It's one of the harder maths. You have to be able to do this. So this is a trick. Hopefully it helps you. Hopefully this video helps you tackle this question. Chapter 7e, question 3b. Aside from that, guys, thank you for watching this video, and I'll see you in the next video.